Hello everyone, welcome back to my channel. So in this video we are going to learn about binary codes. Okay, binary codes and some of the classifications of binary codes. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so what is binary code? Digital data. Okay, so digital data is represented, stored and transmitted. Okay, so digital data is represented, stored and transmitted as group of binary digits, as group of binary digits. In short we will call it as bits. Okay, known as binary code. Okay, so digital data is represented, stored and transmitted as group of binary digits called as binary code. Okay, so I'll explain you through examples. Okay, when I discuss different types of binary codes, how this digital data is represented, I'll tell you so clearly. Right, so next is classification of binary codes. Okay, so classification of binary codes. In that, first classification is weighted codes. Okay, weighted codes. So in weighted codes, each bit position has specific weight. Okay, each bit position will have the specific weight. So examples of weighted code are 8421, 2421, 5211 or 742 bar, 1 bar, etc. So all these are examples of weighted codes. So what is weighted code is every position will have some specific weight. Suppose take 8421 code. Okay, so 5211 is another code, 742 bar, 1 bar is another code. Okay, so the weight of this LSB position is 1, weight of this bit position is 2, weight of this position is 4, weight of this position is 8. Similarly, 5211 is the weights allotted to each and every corresponding position, and bar over it. Okay, so if you have a bar over it, it represents a negative sign. So this position weight is -2 and this position weight is -1, and this is anyhow 4 and this is 7. Okay, so if you have a bar over it, so it is representing a negative number. Suppose if you want to represent 0. Okay, so anyhow 0 is represented with 0 0 0 0 only in all the codes. Suppose if you want to represent 1, so 0 0 0 1. So this 1 multiplied by the corresponding weight will gives you the corresponding decimal number. So if this is your decimal number. Okay, so 1 multiplied by this 1, so 1 into 1 is 1 in binary. So similarly here also 0 0 0 1, and here it is 0 1 1 1. So 4 minus 2 is 2, right? So 2 minus 1 is 1. So again you will get decimal number 1 here. So this is the representation of 1 in 742 bar 1 bar code. Similarly, if you want to represent 2, it will be 0 0 1 0. Okay, 0 0 1 0, because 1 multiplied by the position weight is 2 here. Okay, so position weight is 2, so 1 multiplied by 2 is 2 in decimal. Okay, so in order to get the corresponding decimal number, you have to multiply the numbers where you have 1 with their corresponding weights. Suppose 2 if you want here, right? So you can write in two ways, 0 1 0 0 you can write, or 0 0 1 1 also will become 2 only. Okay, so this 1 multiplied by this 1 will be 1, 1 into 1 is again 1, so 1 plus 1 is again 2, or directly you can write 1 into 2 is 2 only. Okay, there are two types of representation for 2, right? So if you want to represent 2 here, how can you represent 2? 0 1 1 0. So 1 into 4 plus 1 into minus 2, weight is minus 2 here. Okay, so that is why it is called as weighted code, right? So 4 minus 2, which is equal to 2 again. Suppose if you want to represent 5, if you want to represent a decimal number 5 here, so how can you represent a number 5 here? 0 1 0 1. Suppose if you want to represent 5, so here 1 0 0 0. Okay, and here if you want to represent 5, how can you represent? Suppose if you want to represent 5 1 0 1 0. Okay, so 1 into 7 is 7 plus, so this weight is minus 2, so 1 into minus 2, so 7 minus 2 is 5 again. Okay, so this type of codes where you are having specific digit position will have the specific weight. So the weight of this position is 4, the weight of this position is minus 2, the weight of this position is minus 1. So such type of codes are called as weighted codes. Okay, so always remember, bar over it represents a negative weight. So if you have 2 bar, then the weight of that position is minus 2. So if you have 1 bar, the weight of that position is minus 1. Okay, so I hope you have understood the weighted codes, right? So you can write any number of weighted codes like this. So second classification is non-weighted codes. Non-weighted codes. Okay, so non-weighted codes. So non-weighted codes, each bit position does not have specific weight. Does not have specific weight. Okay, so each bit position, if does not have specific weight, then that type of codes are called as non-weighted codes. So examples of non-weighted codes are XS3 code and gray code. Okay, XS3 code and gray code, right? So just remember that XS3 code and gray code are examples of non-weighted codes. We will discuss about XS3 code and gray code in my next videos. Okay, so let me take one more slide. I'll explain you some more classifications of binary codes. Okay, so next classification is, the third one is alphanumeric codes. Okay, so third classification is alphanumeric codes. So the codes which consists of both alphabets and numbers, both alphabets and numbers are called alphanumeric codes. Alphanumeric codes. Okay, so the name only specifies alpha represents alphabets, right? So numeric represents numerals. So which has both alphabets and numbers are called as alphanumeric codes. So there are two main two types of alphanumeric code. One is ASCII code and second is abcd code. Okay, so there are two main classifications of alphanumeric codes. One is ASCII code, second is abcd code. So ASCII code stands for American Standard Code for Information Interchange. Okay, American Standard Code for Information Interchange. Right, similarly Abcd code stands for Extended Binary Coded Decimal Interchange Code. Okay, so this is the first difference, right? And second is it is 7-bit code. Okay, that means each literal will be coded into 7 bits. So this is 8-bit code. 8-bit code. Okay, so ASCII is most widely used code. Right, so it is used in IBM computers. So it is mostly used in IBM computers. Okay, so since it has 7-bit code, so it will have 2 power 7 characters. 2 power 7 characters, that is only 128 characters. And similarly, since it is 8-bit code, so it has 2 power 8, that is 256 characters. Okay, so in the keyboard also we are using ASCII code only, right? Keystrokes always represents the, so in keyboard we'll use ASCII codes only, right? So the letters from A to Z in ASCII code, so in ASCII code the letters from A to Z are represented by 65 to 90. The numbers, the decimal number 65 to 90 represents the letters A to Z in ASCII code. Similarly, the letters A to Z, small a to small z, represents 97 to 122. 97 to 122 represents the letters from small letters from A to Z. Capital letters from A to Z represents 65 to 90, decimal number 65 to decimal number 90. So totally it will have 128 characters, that is 128 decimal numbers it is representing. So out of that, 65 to 90 represents capital A to capital Z, 97 to 122 is small a to small z, and numbers 0 to 9 are represented from 48 to 57, totally 10 numbers. So all these are the decimal values for these values in keyboard also. So in keyboard also we'll follow ASCII code, and these are the ASCII values for letters A and numbers 0 to 9. Since it contains of both letters and numbers, so it is an example of alphanumeric code. Okay, so this is the difference between ASCII code and abcd code. So it is an 8-bit code. Okay, so each number here in ASCII code is represented with 7 bits. Suppose letter A is there, so its corresponding decimal value is 65. So how to represent 65 in 7 bits? So sorry, in 7 bits, so it will be, so 7 bits means it will be 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, 2 power 0. So if you want to represent 65, so it will be 64 plus 1. So 0, 0, 0, 0. So this is the representation of our A in ASCII code. This is the representation for A in ASCII code. Suppose if you want to represent small z, right? Small z. So what is the representation of small z? It is 122. So 122. So how can we represent 122? So this is 64 plus 32. 64 plus 32 is 96. 96 plus 16. 96 plus 16 is 102. 112. 112 plus 8. 112 plus 8 is 120. 120 plus 2 is 122. So this is the representation of 122, and hence this is the representation of small z in ASCII code. Okay, so in the competitive exams, if they ask you to find the corresponding ASCII code for letters or small letters or numbers, you just have to find its corresponding binary value and represent in 7-bit codes. Okay, so don't forget that you have to represent in 7 bits only, because ASCII code is a 7-bit code. Okay.